finish it off.
All right, 3.4, properties of logarithmic functions. All right, so these are the product rule, quotient rule, and the power rule. So remember, product rule, log of a product is equal to the sum of the logs. Quotient rule, log of a quotient is equal to the difference of logs. And the power rules, just throw it out front. And those work back and forth as well. They can work the other way around. So, assuming x and y are positive, use properties of logarithms to write the expression as a sum or difference of logarithms or multiples of logarithms. So it's just saying use all the rules that we have. So give ln of 9y So this is a product, so the log of a product is equal to the sum of the logs. So this is going to be equal to the ln of 9 plus the ln of y. Now, I would say like leave it here, but I'm going to show you the book actually continues on. I don't really know why, because it's not necessary, but they break it down even farther. And so they rewrite this as the ln of 3 squared plus the ln of y. And then they do the power rule, which is to throw it out front. So we throw the exponent out front to get 2 ln of 3 plus the ln of y. And that's where they leave the answer. I don't really care. I probably, if I hadn't seen how the book wrote it, I would have left it the initial way. Like, there's nothing that would have indicated to me that I needed to continue going. So, totally up to you where you stop, but if the answer in the book doesn't match, or, you know, on like the AP, like multiple choice question, if you're like, my answer's not there, that could be why. Let's see, 4. Log of 2 over y. So this is a log of a quotient, which is equal to the difference of logs. It's always the top minus the bottom. So this one would be log of 2 minus the log of y. And nothing further to do with that one. 6, we've got log base 2 of x to the negative 2. So this one, we just have the power rule. So whatever's in the exponent just gets thrown out front. So this would be negative 2 log base 2 of x. So those are kind of all like, they basically were individual things. Sometimes we end up with things where we have to do multiple of these steps in one problem. So obviously in 2 we kind of ended up doing multiple steps, but we didn't need to. We could have just done the one, like we just do the log of a product, we just do the log of a quotient, or we just do the power rule. But sometimes we have multiple things thrown together in one. So like number 8, log of x y cubed. So what situations do you see that we're going to be dealing with here?
Multiplication and power.
Yep, multiplication and power. As you get more comfortable with it, if you can do it all in one step, I'm okay with that, but I am going to show it in 2 steps because that's technically what is being done. So I'm going to do the log of a product is equal to the sum of the logs first. So that's going to be log of x plus log of y cubed. Then I'll go ahead and do the power rule. So that's going to be log of x plus 3 log of y. So if you had wanted to go straight to log of x plus 3 log y because you saw it, you can. I would just say be careful as you're getting used to them. Like I think we may have done a little bit with these last year, like introducing them just for the sake of time. I don't think we did a lot with them. But as they get more complicated, I wouldn't say you need to write out every single step, but I would just say be careful when you are doing multiple things at the same time. 10, we've got log of 1,000 x to the 4th. So this one's going to look a little different because of just the nature of how it works. We're going to still split this one like we did in the last one into log of 1,000 plus log of x to the 4th. So with the second part, I know I'm just throwing the 4 out front, so this is going to be plus 4 log of x. But with this first part, what do I know about the log, this log? What type of a log is this? Base what?
10.
Base 10. Okay. So I know that that's really log base 10 of 1,000. I know that 1,000 can be rewritten how? 10 cubed. So I could rewrite this as log base 10 of 10 cubed. Now, obviously, normally we don't write the base 10 when it's a base 10, but I'm doing this so you see it. Now, thinking all the way back to before Christmas, I know, so long ago. What happens, Riley?
You get rid of the 10, so it's just a 3.
Just a 3. So the final answer is going to be 3 plus 4 log of x.
That's like the one thing I got that whole semester. There's one thing.
So if you had not rewritten this as 3, okay, I would probably take off like 1 point, but you would at least have needed to write log of 1,000 plus 4 log of x. But when it's something like that that can cancel, that's a little different than this up here when I said like ln of 9 plus ln of y. Like ln of 9 is not something that you know. Like the only reason this one I would take points off if you didn't finish is because that's something you should know. Like a base 10 of a 10 to a power, you should be able to do that. So anytime you have something that's an increment of 10 and a common log, make sure you check that to see if it can be rewritten in that situation. Now, there's not like a ton of problems that end up working out that nicely, but if it ever does, then you know. Let's see, 12. ln of the cube root of x divided by the cube root of y. So before I even start this problem, I would try to rewrite it in a different form. Okay, so I would have ln of x raised to the 1/3. Okay, remember, because if we have a root, we can rewrite it as a power, as a fraction, over y to the 1/3. So now, what am I dealing with? Power and what else? Huh? Difference. Difference.
Difference.
Whatever.
I was like, didn't she just say it? Why aren't y'all saying it?
I know, well, she said difference, and then
okay.
she was like, I mean quotient, and I was like,
I
no.
thought she was saying division.
I said division.
Well, division, difference, whatever. Same thing. You knew what it was supposed to
I
be.
knew Plus, it's like minus and subtract. Tomato, tomato. It'll be good. Yeah.
Minor details. All right, so this would be then, again, it's top minus bottom. So ln of x to the 1/3 minus ln of y to the 1/3. Then we take the power and we throw it out front. So we've got 1/3 ln of x minus 1/3 ln of y. Now, book leaves it here, but is there anything else you recognize that we might be able to do?
We could move the 1/3 out and like have 1/3 parentheses ln x minus ln y.
Yep. So, again, mainly just showing you for a notation thing should it get to that, but 1/3 ln x minus ln y. Just because you never know the form that they're going to end up writing it in. I think it's funny that the book stops where I boxed it on this problem, but on that first problem we did, they kept going. Like, I would be more inclined to do this than I would have been to do that, what they did in the first problem. I don't know if they did it just to show up, like, to prove a point, or if there was, like, some legitimate reason behind it, but, you know, whatever. All right, so now we're going to work backwards. So we're going to start with, say, what's boxed, and we need to get back to what's written in black, okay? So the instructions officially say, assuming x, y, and z are positive, use properties of logarithms to write the expression as a single logarithm. Now, something I'm going to point out. Notice, logs are written multiple times when we have split it. When we put it back together, it's not ln of the cube root of x divided by the ln of the cube root of y. It's just ln of the cube root of x divided by the cube root of y. When you're condensing it, okay, so what we just did was expanding, so when we're condensing it back down, it only is written once. Okay, you should only have one log or ln written. Okay? So, 14, log of x plus log of y. So this one is, no, go ahead.
Log of x, y.
Yep.
Okay, that would be really embarrassing if I got it wrong.
All I was going to say is it's the sum of the logs, so we need to do what? So we need to take the product, and then that's how, obviously, that gets left, just like that. 16 ln of x minus the ln of y. So this one is the difference, which means we need to do what? Okay, and which one's going to go on top and which one's going to go on bottom? Yep, so it's always top minus bottom. That's why I emphasize it, so like on those couple problems we had up there at the top, so that you would know by the time we get down here which way it works. So this is ln of x over y. Um, 18 1/5 log of z. So how would this one be condensed? Log of z to the 1/5. Now, totally fine there, but notationally, what's another way I could write it?
I was gonna say log 5th root of z.
Yep. Log of the 5th root of z. So either of these would be totally fine, for the sake of notation. More than likely, they are going to write it in the root, but it just depends. Textbook to textbook could be different things. You never know. 20. 4 log of y minus log of z. So again, this one has multiple things happening, so you can choose to do it all at once if you would like, or if you want to do it in 2 separate steps. Probably for the sake of showing you, I'll write 2 separate steps, but if you're like, I can skip that step, go for it. I don't care. So what do I have happening?
Log y to the 4th over z.
Okay, so I'm going to rewrite it first as log of y to the 4th minus log of z. Okay, just so we see it. And then write it as a quotient, which would be log of y to the 4th over z. So you can go straight to what's in the box, but all right. 22. 3 ln of x cubed y plus 2 ln of yz squared. Now, I'm not 100% sure why they left it like that, because that would not have been expanded all the way. So, if you happen to be like, oh, that's an acceptable way to leave it, no, you would have needed to expand it farther if that was the instructions. You couldn't have just left it like that. But all they want us to do is condense it. So this is a problem because there's a lot happening that I would recommend you do step by step. Okay? So what do you notice, or what are the things that you notice we have going on in this problem?
So we have a 3 and a 2, and those things are in front of the ln.
So those are going to be,
Powers.
they're going to be powers. I've also got what else going on? What other situation? Yeah, addition, so product.
Multiplication. Like x cubed.
Oh, inside. I was like, what? I was like, we just said that. All right, so step by step, I'm going to have ln of x cubed y, all that cubed, plus ln of yz squared squared. So I would take that power personally and put it on each thing before you go any farther. Don't combine them yet. Now, just me, if you feel like I got this under control, be my guest. But I would rewrite this as ln of x to the 9th y cubed plus ln of y squared z to the 4th. Then I'm multiplying, okay, because it's the sum of the logs, so it's a log of a product. So it's going to be ln of x to the 9th, and then it's y cubed times y squared, which is going to be what? Y to the 5th. Just making sure I wasn't going to trick you after Christmas. And then z to the 4th. So if you feel like there's a step in there you can leave out, that's fine. But I wanted to make sure you see all the steps, because when they get a little chaotic like this is when mistakes tend to be made in this type of problem. All right. The last thing for this section is change of base formula, which I used to not really like. When I was in school, I used to not understand change of base. I was like, I don't get it. It doesn't make sense. It's actually really easy. And it's the way that if you have a calculator that doesn't allow you to put in a log base something, it allows you to solve it. So like last year, I think it was Peyton, she had like an older calculator, and she couldn't type in a log base. Like if she hit math and arrowed down, log base wasn't an option. And so when it came time to a quiz or a test, I was like, well, you can use mine because like hers didn't have it. But once we learned log base, I was able to show her how to type it in. So anyways, I'm not sure if this would have been in your notes anyways, if you had it, but if we had, log base b of x, and we wanted to change the base to log base something else. Now, usually we're changing it to a common log or a natural log when we're doing it because we're trying to make it something easier. But what happens is it's log base a of x, so that's the change of base to whatever our new base is, divided by log base a of b. If it was just trying to change it to a common log, it would be log of x over log of b, which is what every problem in the book actually has us doing. They teach you change a base, but then they change everything to base 10 or natural. So, you know, be that as it might, that's how you do change base that way. So, some examples of that. Says use the change of base formula and your calculator to evaluate. So basically it just says, like, put it in as change of base. Check it using that manipulated one, and then also check it by putting it into log base, but I'm not going to make you do that part. So 24 log base 5 of 19. So not something we know, not something we can rewrite a different way to make it something easy like we were doing back in like 3.3. It's not like log base 5 of 5 squared where it's something easy that we know. This is not something we know. This is going to end up being some sort of a decimal. More than likely, it's at least not going to be a whole number. So change of base formula would mean that we write log of 19. So it's whatever the big number is divided by log of the little number. And when you do change a base, log is written both times. It's not like when we were doing the condensing and expanding when we're like, no, it's only written once. Anyway, so you would just type in, hit the log button on your calculator, 19 divided by, and if I think a parentheses pops up, make sure you hit that. So otherwise you have a log and a log, divided by log of 5, and that's going to give us, Josh, did you already type it in?
How many decimals?
Just 2. 1.83. Now, something else to notice is that no matter what base you change it to, you're going to get the same answer. So if you chose, because like these ones don't specify, some of the problems will specify, but like if you did ln of 19 divided by ln of 5, you're going to get the same thing. I'll let Josh check it. 1.83. Okay.
My calculator is
Not going to steer you wrong on purpose.
I know, I was just making my calculator work.
26 log base 12 of 259. So that would be log of 259 divided by log of 12. While you put that in, sometimes the base is going to be a decimal. We've seen that before. If it so happens to be a decimal or something, obviously it works the same way. It's not going to change anything.
What did you get?
2.24.
I guess right at least now.
All right, now those ones all had numbers in them, right? They were only numbers, there were no variables. So I was able to actually get a number. These next problems say write the expression using only natural logarithms. So 30 log base 7 of x. So natural log, we would have ln of x over ln of 7. There's nothing I can do with that other than just leave it, okay, because I don't know what x is. 32 still wants us to use natural logs. Log base 5 of C minus D. So again, things that we don't know. So this is going to be ln of C minus D divided by the ln of 5. Now, some people, because this is subtracting in here, get excited and think, oh, that's C divided by D. It's already condensed into one log, so it's not, okay? That would only be the case if it were two separate logs, like the ln of C minus the ln of D. So that's why it stays just like that. Same exact thing, but with common log, so just log base 10. 34 log of 4, or log base 4 of x. How would I write this one then, using common logs?
Log of x over log of 4.
Log of x over log of 4. And last one, log base 1/3 of x minus y would be what?
Log of x minus y over log of 1/3.
Yep. Now, the book does write it differently because of there being a fraction there, but I would just leave it like that. They do some weird negative stuff and make it whatever. It's that, again, I don't know why they do that one that way, but not the other one that way. It's whatever. That there's another one like it. All right, problems are 1 through 35, every other odd. I think everything in that set you should be able to do just fine. And that should give you, yeah, well, I was going to say it should give you one of each type of the change of base. There's only a couple minutes left, so I'm going to ask you, do you want to have some time tomorrow when you come in, or do you want to just do this for homework since it's kind of short? Okay, and 3.5 notes are only, I think, 3 minutes, so.
Yeah.
Really short.
Because it's a bunch of word problems.
No.
But they're not hard, though, like, honestly.